They thought it might be here, somewhere in the darkness of a cave. Way down deep, buried deep. Deep into the cave they went. And if they were able to find it, will it be the most important mathematical discovery of all time?
Find out on this episode of Math with Matthew.
It's Math with Matthew, so go kick off your shoes. Increase your worldview, it's Math with Matthew. X equals 3.
Think about this, Rhombus. Thousands of years ago, the Egyptians, the Babylonians, and the Greeks discovered, developed, and then proved the amazing powers of a single geometric formula.
Formula?
A power that shaped the way we solve problems involving right triangles.
Right triangles?
An equation that led to the discovery of monumental structures.
Structures.
And the discovery of irrational numbers.
Irrational numbers? Wait, that's not rational.
That's true. And would you believe it all started on a small clay tablet?
No.
Well, it did, and that's why we're here. You see, it was written in an ancient Babylonian base 60 number system, and it was named Plimpton 322.
Plimpton.
And when Neubauer and Sachs deciphered it in 1945, it was the first evidence of the Pythagorean triples.
What's this blue light over here?
Oh, Rhombus, are you being distracted by shiny lights again?
Probably.
Rhombus, what's this blue light?
Nice job, Matthew!
I think if we turn this light into a right triangle, it will lead us to the priceless artifact. Yes!
Matthew! I found it! I found it! The first evidence of the great Pythagorean triples! Ah!
Sometimes I wonder how he actually makes it through the day. Luckily, tragedy was averted. Rhombus never dropped the tablet. It was transported safely back to my math lab. Now, this lab is where we develop, explore, and learn about the important mathematical concepts that can be applied to the real world.
Race you there.
Hey, Rhombus, wait for me! Hey, I know a faster way how to get to the math lab. And here we are. Let's wait for Rhombus.
Matthew, how'd you beat me here?
The power of mathematics and some clever camera work.
Wow, it's beautiful.
It's brilliant.
I just want to hold it. Maybe let's just leave it where it is.
Rhombus, this artifact is very important for the work that we do here in the math lab. It will help us better understand the history and development of the Pythagorean theorem.
Matthew, what is this Pythagorean theorem you keep on talking about?
I'm glad you asked. I think it's time for you to begin to understand the Pythagorean theorem.
Look at a right triangle with a 90-degree right angle. Across from the right angles, the hypotenuse. It's no surprise the hypotenuse is the longest side. Now how do you find the hypotenuse's length if you know the length of the two other sides? Let's take you back to old ancient Greece. Pythagoras is gonna show you why. A squared plus b squared equals c squared, where c is the length of the hypotenuse. A squared plus b is a delicate calculation. To find the hypotenuse, take the square root of the sum of the two other sides squared, and then compute.
So rhombus, are you beginning to understand a little bit about the Pythagorean theorem?
Yeah, Matthew, I think I got this Pythagorean theorem. But that video wasn't really speaking my language. How about I give it a shot in my own words?
Pythagoras, Pythagoras, Pythagoras.
Step 1, find the corner that's 90 degrees, cause a right triangle has one of these. Step 2, take an adjacent side, multiply it by itself and set it aside. Step 3, do it again. With the other leg, square it and then. Step 4, add a squared to b squared, now what have you got? The square of the hypotenuse, that's what I thought. Step 5, take the root of c squared with all of your strength. Now you found c, the hypotenuse length. You got it? I think I got it. Pythagorean theorem in my head. Solving for C, solving for B, solving for A.
Pythagoras, 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 Pythagoras.
It gets the secrets out of triangles, small or big. A squared plus b squared equals c squared, you dig? Pythagoras had his theorem nailed down tight. For solving right triangles, it's out of sight. If you got a right triangle you wanna school, study Pythagoras and follow his rule. Oh no! Then the song's nearing, that ends the Pythagorean theorem.
Pythagoras.
Rhombus, I think you got it now. Nice job.
So Matthew, one thing I was thinking about, back when we were in the caves looking for the tablet, you kept on talking about Pythagorean triples. What are those?
Well, I'm glad you asked, Rhombus. Pythagorean triples are whole number distances that satisfy the Pythagorean theorem. For example, a 3, 4, 5 unit right triangle, a 6, 8, 10 unit right triangle, or a 5, 12, 13 unit right triangle.
Okay, I think I get what a Pythagorean triple is. Well, you mentioned this was the most important discovery of all time. Well, why is that?
Well, not only is it used in algebra, geometry, and trigonometry, but also it can be used in buildings, architecture, astronomy, and even art.
Is this more important than the discovery of zero, negative numbers, pi?
I believe so. Not only can it find the missing side lengths of right triangles, it can also determine if a triangle is in fact a right triangle. It has many practical applications. Play ball!
Here we are in the bottom of the third, man on first, and batter up. Here's the pitch. He's trying to steal. Oh no, he threw it into center field.
That's all right, Catch. You can do it, buddy. You can do it. Let's get it back next time, Catch. You can do it. Here we go. Take your time now. Here we go, boys.
Okay, let's try that again. Here we are in the bottom of the third, man on first. Here's the pitch. Oh, he's trying to steal. Oh, no, the throw is short. That's an error.
Oh, come on, Catch. Oh.
Time! Time! Hey, Catch, come with me. I think I can help you out. I'm going to help you make the perfect throw from home plate to second base.
Well, I want to. I'm just having trouble determining the distance between home plate and second base.
The distance from home to first base is 90 feet, and the distance from first base to second base is also 90 feet, and it forms a right angle. This will form a right triangle with the distance from home to second base being the hypotenuse of the right triangle.
Okay. So using the theorem a squared plus b squared equals c squared, we can find the distance from home to second base?
Exactly. So we have one of the legs, which represents 90 feet, and we square that distance of A. And then we have the distance of the other leg, which is also 90 feet. We square that, and that would give us the hypotenuse squared. So what would be 90 feet squared?
8,100 feet.
Yep, 8,100 feet squared plus 8,100 feet squared would give us our hypotenuse squared. So what do we need to do now?
16,200 feet.
We add it together and we get 16,200 feet squared, and that is our hypotenuse squared. And now what do we need to do to get the distance of C?
Find the square root.
Find the square root. Take the square root to both sides. The square root of 16,200 feet squared is 127.3 feet, and that is the distance of the hypotenuse of the right triangle, which is also the distance from home to second base.
So if I throw the ball 127.3 feet, it will land exactly at second base?
Exactly, and you'll get the runner out.
I can do that.
All right, good luck, catch.
Thank you.
Let's see how he does on the next batter. Here we are in the bottom of the third, man on first, and here's the pitch. He's trying to steal.
See, Rhombus, the Pythagorean theorem does work.
Sure does, Matthew. Gotta say though, I've been looking to try to find this Pythagoras guy everywhere and I just can't find him. I've checked Facebook, Twitter, Snapchat, nowhere to be found. What gives?
Well, two things, Rhombus. The first is that Pythagoras lived 2,500 years ago. And the second is that Pythagoras and his group of followers were a very secretive group. In fact, they had a very specific and interesting set of rules in which they did mathematics.
Rules? Like what?
You know, I think it's time that we learn about how Pythagoras and his followers did mathematics through a game of Survivor on the island of Pythagoras.
Are you a math teacher?
Yeah, you?
I am.
Huh. So, what are we doing here?
I don't know, I think we're gonna meet someone, do some math problems, I'm not sure.
All right.
So, what's your deal? Do you even teach math?
No, I'm a rap teacher.
Oh, sweet.
Welcome, math teachers. I am Pythagoras of Samos. You are here today to solve some mathematical problems while following all of the rules of the Pythagoreans. The last one to break the rules is the winner. Yes?
What are these rules?
I will let you know if you break any of the rules. And if you do, you are out. Are you ready? And we begin. You, with the mirror. Pythagoreans do not look in a mirror by fire. You are out!
You gave me this hair. I just wanted to look at it.
Continue. Are you eating beans? Pythagoreans must abstain from beans. You are out!
But the Sasquatch said it would give me beautiful hair.
Are you stirring fire with iron?
Yes.
You cannot stir fire with iron. You are out!
But that's so irrational.
Wait, did you pick up what had fallen?
Yeah.
Pythagoreans may not pick up what has fallen. And for that, you are out!
You know what? I'm glad. I'm so Pythagorated.
Pythagoras! I got the answer!
What is the answer to the problem posed?
The square root of 13.
That cannot be the correct answer. The square root of 13 is irrational. and Pythagoreans only believe in rational numbers.
I got the right answer, and I'm still wrong?
That's correct, and you are out! Kate, you have won the contest.
But I didn't even finish solving the problem yet.
That is true, but you are the only one who did not break any of the rules.
Well, what do I win?
You have won a brand new 60-inch television set.
Wow, that is great. Where do I pick it up?
You must find the television set that is exactly 60 inches in the diagonal using my Pythagorean theorem. And you only have 2 minutes to do it. Are you ready?
Not really.
Good. Now let's have a go.
Less than 2 minutes, what will I do? But first I might need some math review.
Hey everybody, she's on the loose. Let's hope she finds the hypotenuse.
The hypotenuse, that's what I need. Now I know how to solve for C.
Can she do it? I have my doubts. Look at the time, it's gonna run out.
Need a diagonal of 16 or more. I'll try the TV, that's 33 by 44.
Okay, folks, she just might do it. The Pythagorean theorem, I can't believe she knew it.
Oh no, this doesn't seem to jive. I got a diagonal that's only 55.
So far, I'm pretty impressed. She's got one down, but not much time left.
I'm worried I'll be a few seconds late, but I'll try the one that's 36 by 48.
Not much time, she's starting to sweat. She may not win this TV set.
I found the hypotenuse, it is 60. Now that's a mathematical shopping spree.
Rhombus? Rhombus!
Oh, sorry, Matthew.
We need to spend a little bit more time talking about the Pythagorean theorem.
Okay.
Now, so far, we've talked about the Pythagorean triples, the Pythagorean theorem through a variety of songs, and the Pythagorean theorem and how it can be applied to the real world with baseball and with TVs. So, what I need to know from you is, are you willing to declare that the Pythagorean theorem is the most important mathematical discovery of all time?
Not yet.
What more do we have to do?
How do I know if this works with every right triangle? I want some proof before I make that kind of a statement.
Proof? Rhombus, we're mathematicians. We know proof. And so now we begin the proof of the Pythagorean theorem. We start with a given that we have a square with 4 right angles and 4 congruent side lengths. And inside of it is another smaller square that also has 4 right angles and 4 congruent side lengths. We're going to call the larger square side lengths A plus B. And because all sides are congruent, they're all A plus B. And inside is the smaller square that has side lengths of C. And from this information, we can now prove the Pythagorean theorem. It will be done by determining the area of the larger square 2 different ways. Let's begin by finding the area of the larger square based upon the side lengths of A plus B. So, the area is A plus B times A plus B. We use the distributive property to distribute the A plus B to itself, and we have A squared plus AB plus AB plus B squared. And we can combine like terms of AB plus AB to get 2AB. So the area of the larger square is A squared plus 2AB plus B squared. Now, let's find the area of that same large square a different way based upon the 5 inscribed figures, the 4 right triangles and the smaller square. The 4 triangles are all congruent because they have the same base and height of A and B. So the 4 triangles will equal 1/2 A times B, and we add that to the area of the smaller square, which is C times C. Again, using the distributive property, 1/2 of 4 is 2, so the area is 2AB plus C squared. That also is the area of the larger square. What we can do now is set the 2 areas together, equal to each other. And we have A squared plus 2AB plus B squared equals 2AB plus C squared. If we subtract 2AB from both sides, what we are left with is A squared plus B squared equals C squared. And if we look back at the right triangle, the A and the B refer to the legs and the C refers to the hypotenuse. So, for any right triangle, if you take the distance of one of the legs and square it, and add it to the distance of the other leg and square it, it's going to equal the distance of the hypotenuse squared, hence the Pythagorean theorem. Well, Rhombus, are you now convinced that the Pythagorean theorem is the most important mathematical discovery of all time?
No.
What could be more important than the Pythagorean theorem? Oh, that'll be for our next adventure when we explore pi. We'll see you next time.
Hey,